Hello everyone, welcome to QualityMunch. I am Jitendranath and today we are going to talk about the number 7. Did you know there is something special about the number 7? It's like a magic number with so much significance in various aspects of our world. 7 continents shaping our planet's diversity. 7 wonders of the world captivating our imagination. 7 days of the week structuring our time. 7 chakras balancing our energy. 7 colors of the rainbow painting the sky. 7 seas connecting our lands. 7 musical notes harmonizing melodies. 7 phases of marriage symbolizing eternal love. And yes, 7 on MS Dhoni jersey inspiring greatness on the field. Today, we are not only here to appreciate these connections but also to introduce you to another set of 7 that's going to empower your quality journey. These tools can supercharge your efforts to enhance quality in everything you do, be it at work or in life. So I invite you to join us for both parts of this series. Watch, learn, and let's make quality a secret ingredient to success. Today, we are going to learn about the 7 QC tools popularized by Dr. Koru Ishikawa. Dr. Koru Ishikawa once stated that up to 95% of quality related problems in the factory can be solved with 7 fundamental quantitative tools. So, which are these 7 quality control tools? Flowchart, check sheet, cause and effect diagram, histogram, Pareto chart, scatter plot and control chart. Let's explore them one by one. These tools are essential in quality management and they can significantly improve processes and identify areas for enhancement. Stay tuned as we delve deeper into each tool and discover their potential in solving real-world quality challenges. Welcome to the exciting world of flowchart, or first stop in the journey of 7 QC tools. A flowchart is like a visual roadmap guiding us through the steps in a process using symbols and arrows. Flowcharts are useful for everyone, whether you are familiar with the process or trying to understand it for the first time. It helps us understand the sequence of actions and decisions involved, making complex processes easier to grasp and communicate. They allow us to analyze and optimize workflows, spot bottlenecks, and enhance overall efficiency. Let us see this with the simple example in next slide. Let's explore the flowchart using a simple example, grocery shopping. To begin the process, write a grocery list. Here, list down all the items needed from the store. Meanwhile, let's explore the 4 primary flowcharting symbols. The oval shape represents the beginning and end of the process. The arrow shows the direction of stages in the process. The rectangle symbol represents processing, operation, or activity. The diamond shape indicates a decision point in the process. Moving back to our grocery shopping example, the decision point asks, are all the groceries available at home? If yes, everything is available at home. No need to go to the store then. But if any items are missing, go to the store to buy the missing items. After that, it's time to purchase all the groceries from the store. And there you have it. It is an example of simple flowchart to make you understand the basics. Welcome to slide number 4, check sheet. A check sheet is a valuable tool that comes in the form of table or form with the categories to mark occurrences or observations. It helps us track and tally specific events or frequencies. Let's understand the key points about the check sheet. The purpose of check sheet is to gather accurate and reliable data that can be used for further analysis and decision making. Check sheets can be customized for specific needs, such as tracking defects, counting occurrences, or recording observations. Using a check sheet helps collect data consistently, identify patterns, and highlight problem areas. On this slide, we have a practical example of a check sheet for defect tracking. Here we have listed various defects like flow crack, blister, cord visible, flash, and serial number misplaced. On the right side, we have frequencies of these defects observed on each day. Inspectors use tally marks to record the occurrences of each defect they find during the inspections. And at the end of the day, we have the total count of each defect for that day. For example, on first day, we had a total of 17 defects. Out of these 17, there were 7 flow cracks, 4 blisters, 1 cord visible, 3 flashes, and 2 serial number misplaced. We can see that flash defect is occurred 31 times with top rank, and on 4th day of the week, highest number of defects were observed. Before we proceed, let's clear up any confusion between a check sheet and checklist. A checklist is a list of items that need to be completed before starting work on any project, task, or activity. It ensures nothing is overlooked. On the other hand, a check sheet is a tool used for data collection and tallying occurrences or observations, as we see here in our example. Welcome to this slide of cause and effect diagram. This diagram is also known as Fishbone Diagram or Ishikawa Diagram. It's a powerful tool used to identify various causes for a specific problem or effect. Let's dive into key points about the cause and effect diagram. Categorizing potential causes into branches like man, methods, machines, materials, measurements, and environment or mother nature ensures a thorough analysis of all relevant factors. By breaking down the potential causes into these categories, we can identify different aspects contributing to the problem or effect. After identifying the potential causes in a fishbone diagram, it's essential to validate these causes to ensure their accuracy and relevance. Validating the potential causes helps us eliminate any assumptions and focus on addressing the root causes effectively. A fishbone session is divided into 3 parts: brainstorming, prioritizing, and development of an action plan. In the brainstorming phase, we gather and list all possible causes. Then, in the prioritizing phase, we determine the most critical causes to address. Finally, we develop a structured action plan to tackle the identified causes. Here in this slide, you can see cause and effect diagram made for the problem of high defect rate in a product. Let's explore the key causes that contribute to this issue. Personal or man, machine, material, method, and environment or mother nature are the main branches representing the major cause categories. Under each of these branches, we have primary causes mentioned. For example, under the branch man, we have poor skill, fatigue, and distractions as a primary causes. These primary causes give us insights into specific factors affecting the defect rate related to man. Further, under material, we have substandard material and contamination as primary causes. These primary causes highlight issues with the materials used in the production process. In the man category, we also have secondary causes such as improper way of hiring and no training for new joiners, which contribute to the poor skill factor. These secondary causes help us understand deeper issues leading to the poor skill level of our workforce. Thus, you can create visual representation of probable causes at different levels and further dig out to the root cause with the help of YY analysis.
Thank you for watching part 1 of our video series on the 7 QC tools. I am thankful for your time and attention. If you enjoy this video and found it valuable, please give it a like and share it with others. If you haven't subscribed yet, kindly consider subscribing to QualityMunch for more knowledgeable videos. In our upcoming part 2, we will explore histogram, Pareto chart, scatter plot and control chart. Thanks again for being a part of our QualityMunch community.